Hi, Algebra 1. Today is our last lesson in Chapter 8. We have been talking about multiplying polynomials and then going backwards through the process and talking about factoring. Today we're going to add one more dimension to the factoring, and it's something that we've actually done already at the beginning of this chapter. We're just going to be combining two skills and concepts together. So we're actually going to be merging the same lesson in an example problem from 8.6 and 8.7. So first we're going to be in 8.6 problem 4, and it's page 508. So you can open up your books to that page and you can see what I'm talking about. We have this problem here. How do I factor this? So now we have all of these different skills and shortcuts that we've learned and different methods and different patterns to look for. So if I wanted to start factoring this, I would see that I'm in standard form. 18x squared, ax squared, bx plus c. Which means I could actually go ahead and just make an x form and dive in. However, you might be looking at this and noticing some really large numbers. 18 times 12 would be my ceiling. My b would be negative 33 in the basement. I'd have to do a lot of maybe math work and figuring to figure out how to get those two factors that multiply together to get that really big number, but add together to get b. Guess what? There's something that we haven't had to do yet so far. What do you notice about each of these three numbers? 18, 33, and 12. Well, they have a common factor. They are all divisible by 3. So step 1, when we are factoring quadratics or polynomials, we should always be looking for a greatest common factor. In this case, my greatest common factor is simply 3. So I'm going to go ahead and divide out a 3. So that's going to leave me with my greatest common factor out front. And then I'm going to think through the division here. Remember, it's the opposite of distribution. This divided by 3, this divided by 3, and this divided by 3. Notice for this particular problem, I can't take an x out because my last term doesn't have an x, so it's not a common factor. I can only take a number in this case. So my new math problem is this. Factored out by greatest common factor of 3. Now I have a new quadratic here. Now I'm able to go ahead and do my x form. So let me go ahead and think through that. Here we go. First of all, I'm noticing that I don't have perfect squares here. I do have one here, but I need one here too to match that pattern. So my x form is actually my only way to go. A times c. Notice that when I'm doing my x form though, I'm not reverting back to this quadratic with the larger numbers because I've already pulled out a 3. So once I factored out the 3, this is my new quadratic that I'm factoring. So 6 times 4 gives me 24, and negative 11 goes in my basement. Well, in this case, negative 8, negative 3 are my two sides. If I have a lead coefficient here, this number 6, this tells me I'm going to have to use either divide and slide or my greatest common factor table. I'm going to go ahead and use divide and slide. So I'm never going to lose that greatest common factor out front. We don't just take it out and throw it away. It's still part of our answer. But what I have here first, and this is requiring you maybe to remember how to do divide and slide. If you have those notes handy, pull them out. I know that I write my two sides as my binomials, and then I divide by this 6. Well, I know 8/6 reduces to 4/3. I'm going to use my eraser here. I know 3/6 reduces to 1/2. Notice that neither of them simplified to a nice whole number. So that means my second part of divide and slide, the slide part, has to happen because I take that denominator and I slide it to the beginning. So my final answer is this greatest common factor out front, 3x minus 4, 2x minus 1. Whew. I combined a lot of different skills that we've learned so far in the second part of this chapter. There's a lot going on in these types of problems, a lot to remember. Okay, I'm going to give you one more, just like this, to try. Let me erase and put it up there. Pay no attention to this. We'll get to that next. Okay, so this is where you come in. You get to put all of your factoring skills together for this next problem. And remember, like I said, we are in 8-6 for this particular example. Okay, here we go. If I said to you, factor this, always look for a greatest common factor first. So pause the video and then attack this problem and come back and we'll go over it together. Okay, the first thing I need to look for is a greatest common factor. Notice that they don't all have an x, so I know I won't be able to pull an x. So I'm looking for just a number. 8, 36, and 20, they're all divisible by 4. We can't go all the way up to 8 because this isn't divisible by 8. So 4 is my highest. I already made a mistake. If I'm factoring out of 4, it's not 4, it's 2. Let's try that again. Okay. I pull out my greatest common factor and I'm left with 2x squared minus 9x minus 5. This is now the quadratic that I want to think through factoring. I'm going to make my x form. AC goes in my ceiling. -9 goes in my basement. I know somehow it's going to be 10 and 1. Think through those negative signs. Gives me -10 here. Not losing that greatest common factor out front. I write my binomials like this. But I had a lead coefficient here. It was 2. Remember, I don't deal with 8. After I pull out that greatest common factor, this is my new quadratic. So I'm going to divide everything by 2. Divide and slide. This divides evenly to give me 5. This does not, so there's my slide. So my factored form of this quadratic is 4 times x minus 5 times 2x plus 1. How could I check to see if this was true? Well, multiply it out. I'd start first foiling. And this foiled should give me this. If it doesn't, I made a mistake and I need to start over. But if it did give me this, then I'd need to distribute in a 4. And if I didn't end up here, I'd have to check again. But this times 4 does give me that. Okay, let's move on to the next part of today's lesson. This is jumping ahead to 8-7, where we need to do the same thing, but this skill is going to be combining with difference of squares. Okay, so here's my problem, 24g squared minus 6. Okay, well, first of all, I have 2 terms, so is this a difference of squares? Well, it's definitely a difference, but I don't have perfect squares. Well, I also see that I can take out a greatest common factor. What number divides evenly into 24 and 6? Well, it's 6. So let's take out that greatest common factor and then divide everything inside by 6. Now I look at this and I still see I have 2 terms, but now I can recognize my pattern. I have difference of squares. 4g squared is, let's write it as 2g quantity squared going on here. Don't lose that greatest common factor out front. What about this 1? Is that a perfect square? Sure is. It's 1 squared. So now that I'm using that pattern, I have an a squared minus a b squared. Remembering back to this or pulling out your notes from the last couple of days, I know I need to write this in conjugates with my A plus my B times my A minus my B. So let's write the final answer here. It would have 6 out front. Don't ever lose that greatest common factor. But then my conjugates would come next. 2G plus 1, 2G minus 1. With my 6 out front. This is my simplified factored version of this problem. Okay, I'm going to give you 2 practice problems that use difference of squares. Just kidding, one uses difference of squares, one does not, but look for your patterns first. Actually, first you should be looking for a greatest common factor. Okay, so since we're jumping all around, I'll write these practice problems here on my board, and then you can pause the video and try them on your own. And again, these might be requiring you to use so many of the skills that we've learned in this chapter so far. So don't be afraid to stop the video, pull out your book, pull out your notes, whatever it takes. Okay, go ahead, pause the video, try these 2 problems, and then we will go over them when you're finished. Okay, point of today's lesson is to always look for a greatest common factor first. So in this problem, short and sweet, I can see I can pull a greatest common factor out. Oh my goodness, look at this problem. Look what I did. This is throwing all of you for a loop. Guys, it was supposed to be minus 48. Ah! Some of you are very frustrated right now, and I apologize. Let's try it though the right way. Take out a greatest common factor. What goes into both of these? A 12. Oh my goodness. That had to be frustrating. Okay. Yeah, that would not have worked. Okay, now though we have the problem right. So even if you didn't a second ago, now we do. If I take out a greatest common factor, I'm left with t squared minus 4. That is 2 terms being subtracted, both perfect squares. Well, what is this? This is t squared, and 4 is a perfect square of 2 squared, and I still have this greatest common factor out front. I'm never going to lose it. I don't just throw it away. Using my pattern for difference of squares, I'm going to write my conjugates. Greatest common factor, 1 conjugate, 2 conjugates. Okay, let's attack this next one. I wrote it correctly. Way to go. Okay, first thing I want to do is see if I have a greatest common factor. Do I? I sure do. 3 can be pulled out of each of these. If I pull that out, I have this. What kind of a pattern is this? Or if you don't see a pattern, go ahead and revert to your X forms and you'll get the answer the same way. But I want to kind of train you to be looking for the pattern. Look what I have here. Let's say I write this as 2x squared plus 4x, and I know this last term is also a perfect square. What do I have going on here? A perfect square trinomial. This is a perfect square, this is a perfect square, and what do I have in the middle? 2x times 1 doubled gives me 4x. So I have a perfect square trinomial. What pattern is that? Going back a couple days, that means I have this. And that's how I would write it. If you didn't see that, you would have done an X form, used divide and slide or your greatest common factor chart, and you would have ended up right here anyways. So you can see some of our factoring problems are getting harder. But that's as hard as they're going to get right now. Okay, that's the end of chapter 8. You have some suggested book practice. Some are coming from 8.6, some are coming from 8.7. You'll notice in your book that 8.8 is about grouping, and we're not going to tackle that right now. At the end of the year, if we have some extra time, I will spend some time teaching you that shortcut method. Right now, we need to move on. So you have 2 Khan Academy assignments that correspond with today's lesson. It combines what we did yesterday with what we did today. And those are both due Friday, May 1st at 5 o'clock. Since this is the end of chapter 8, you should start studying for a test. However, I've decided not to make it a test. I gave you a quiz on the first half of the section, or on this chapter, everything that had to deal with multiplying binomials. We're going to have a quiz. I call it a quiz because it's just going to cover the second part of chapter 8. It's going to be shorter than a whole test, and it's only going to cover factoring. So that will be sections 8.5, 6, and 7. So start studying for that over the weekend. I will have available on RenWeb some suggested problems from the book, from the review section and the chapter test that will be helpful. I'll also include the answers for you so that you can check yourself and make sure you're prepared. But stay tuned for an email later this week about the specifics of when that quiz is going to take place. Okay, that's it for this week of chapter 8. However, it's not the end of this week completely in Algebra 1. We have one more lesson tomorrow as we move into the next chapter. Okay, that's it for today. Have a great day.